Okay, so here we have a force of 10 newtons pushing a wooden crate to the right on a wooden floor. The crate weighs 25 newtons, so we know the weight of this crate is 25 newtons. We know the force pushing it forward is 10 newtons. And we know that's wood on wood. So what we want to do now is we want to draw a diagram and label all the horizontal forces that are acting on this crate. Well, knowing that it's wood on wood, we're going to need to know what the coefficient of friction is there. So let me pull up the little table that's in your reference table that gives us all the values for the coefficient of friction. Give me 1 second. Right here. So if we have wood on wood, well, remember we have two values here. We have kinetic and we have static. Whenever the object is moving, we have to use kinetic coefficient of friction. So we have to use 0.3. Whenever it's not moving, we have to use 0.42, static. So wood on wood, the kinetic coefficient of friction is 0.3 because we are moving in this case, right? It says it's moving toward the right. So we know that mu, coefficient of friction, whoops. Oh, what is that? There we go. We know that is 0.3. And again, it's unitless, right? Coefficient of friction doesn't have a unit. We know that the weight, call that Fg, is, what was it, 25 newtons? Yeah. And we know that the force applied to this thing, I'm going to label it Fa. The applied force is 10 newtons. Now what I want to find is the frictional force, right? I don't think they actually asked me to find the value of it. They just want me to draw an arrow to label it. But I want to find the value of the frictional force anyway. Right, so I know I have friction going to the left because I have an applied force going to the right. I'm moving to the right, and friction always opposes my motion. And I have gravity acting downward, 25 newtons, which means I also have a normal force of 25 newtons upward. Remember, the normal force and the gravitational force when you're on a flat surface have the same magnitude, just going opposite directions. So normal force is 25. And we said applied force, Fa, we said was 10. And now I want to find what Ff is, the frictional force. So we have our formula. Ff equals mu times Fn. We said mu is 0.3, and we said Fn is 25 newtons. So all we have to do then is just multiply those two. 0.3 times 25, and let's see what we get. 7.5. So we get 7.5 newtons for the frictional force. Ff equals 7.5 newtons. And then we just answered both 7 and 8 because 8 asked me to label the vertical forces acting on that object. So 7 and 8, all done. Again, the big thing about that is you need to know that the normal force, right, Fn, on a flat surface is the same as the weight. It's the same as Fg, the gravitational force. Fg being your weight. So they gave you your weight, so you know Fn. All you had to do was find the frictional force using that and the coefficient of friction from your reference table. Not too crazy.